Sanbonani, Makdevano. So today we'll be doing theorem number 8, where it's part of the tangent, but this one it's talking about two tangents that are on the same point outside the circle. We're proving that those two tangents, they are equal in length. That's what we are proving. How are we going to prove it? We're going to start by doing construction. What construction? Joining our O here, which is our center, to the tangent here, and again from O constructing it to the tangent. By the way, you need to know how to prove this theorem. Then from O also going to A. When you look at this one, we are forming two triangles. We just formed two triangles here. So how are we going to prove this? If we have two triangles from theorem number 1, siforme ama triangles out 2, wahlangana ama triangles out 2. If ihlangana ama triangles out 2, then we prove it with doing congruency. So congruency, now it's coming back again. We need to prove this theorem by proving the congruency. Then let's start stating our given it. What it's that A, B, and AC yini ama tangent, and then O is a center. And what is required to prove? The required to prove here too is that AB is equal to AC. That's what we are supposed to prove. And now let's prove. Before we prove, state our join. So join OB, so join OC, so join nobani no OA. That's what we joined. Then let's prove now. By proving, we are proving congruency, so must state our triangles. We have triangle OBA and triangle OCA. First thing, our number 1 from theorem number 1. OB, it's what is a radius. OC, it's what? It's a radius. So OB welingana nobani OC. Why? Radi from theorem number 1. I hope you still remember that one. From just theorem, let me just take now, which is theorem number 7. This one is equal to this one. Y tan perpendicular to what? To your radius. So okwesibili, that P1 lingana nobani no C1, y lingana no 90, y is tan perpendicular to what? To your radius. And then now the last one, which is just OC, OA OA, corner to this triangle and corner to this triangle. So what does this mean? Is that OA uyalingana nobani no OA, y is just common side. We just have common side there. 3 things to prove congruence. 3 things that you must get in order for you to prove congruence. Then to see proof congruency, O B A is congruency to a triangle bani O C A, y it's a right hand side. Why right hand side? Because we have this tan perpendicular radius which gives us 90 degrees. So we have right triangle right, which is this hypotenuse side, which is this our hypotenuse side, this right angle hypotenuse side, and we have this side here. That's why we have RHS. Then if sesiphuvile congruency, therefore ubani uAB uyalingana nobani noAC, and we are done. Because proving congruency is proving that all these two triangles are equal. That's what we are proving with congruence. Thank you so much. Okay guys, now we'll be doing the example of theorem number 8 that we just did now. Start by reading our statement, which is one of the important things to do when you doing examples or doing Euclidean geometry or trying to solve any problem revolving Euclidean geometry. Statement is very important. So what they are saying here, they are saying O is the center of each circle, which is one of the circles, this one we are doing now. And then when O is a center, O is a center. If O is a center, we must have a radius. OA, it's a radius. OT, it's a radius. Something that is very important that you need to write it down. OA is equal to OT. What does it tell you? This is a radius, which is a maradi. And then if those are the two, then now this is equal to this. What does it mean? It's meaning this one now is equal to this one. Why I'm saying that? A2 is equal to T2 y angles opposite equal side, which is isosceles triangle. Then from there, now these two are equal. We need to check something else revolving O is a center. Theorem number 2, there is a shape that I'm seeing here, which is this shape. That's involving theorem number 2 when O is a center. The shape where this thing here, this angle here is equal to this one, but twice this is equal to this one. So B, which is twice B, is equal to A O T y angle at the center is equal to 2 times an angle at the circumference and then this one is 2 times this one. O is a center. We're just in that. You see many things that we just found by being O is a center. Now moving on with our statement, we have AP and PT. AP and PT, they are saying it's what? It's a ray tangent, a tangent. So if we have tangent, and also we know that we have O is a center, and now we know that we have a radius. Then now radius and tangent, radius and tangent, radius and tangent. If radius and tangent, now we know that radius and tangent, this angle here has to be 90 degrees. This angle here needs to be 90 degrees. Why? Tan perpendicular radius. So OA2 plus ubani. Oh, let me just say ubani. OAP is equal to OT TP is equal to 90 degrees, y stand perpendicular radius 90 degrees, those two. And then also we have the two tangent. So if we have two tangent, now this one is equal to this one. Why? Because these two tangent are touching this same point, so that's why these two are equal. AP is equal to PT, y tangent from same point. Now if these two are equal, they are forming an isosceles triangle, which is this triangle here. Now if they are forming the triangle, now this angle here, this triangle here is gonna be equal to this triangle here. I hope you see that one. So T3 is gonna be equal to this A yomncane here. Why? Because opposite angle opposite equal to opposite side, which is an isosceles triangle. We were just analyzing the statement. We haven't reached the part where you need to answer question. It is part of just analyzing our diagram and our statement. So from what we have just analyzed, now let's just answer a question that they are supposed to answer. They told us to calculate OA and do B and C, which is our unknown, which is this is A and B and C. From there we can start by calculating A from what we know in this triangle. Since we do have 50 here, we know now this A is equal to T3. So writing like procedurally, you can start by saying AP is equal to PT, y tangent from the same point. Now we are writing it procedurally when you are writing a test or an exam. Then from there, if these two are equal, then OA T3 is equal to A, this small a, y isosceles, where we call it opposite angle, opposite equal side. Now we can use our isosceles triangle here by just saying A plus T3 plus this 50 here is equal to 180, which is just sum of my triangles. A to here, we know A is equal to T3, so we can say A plus A, T3 substitute to A since A is equal to T3, then plus 50 is equal to 180. A plus A is just 2A, and plus 50 then is equal to 180, then 2A is equal to 180 minus 50, then 180 minus 50 is just 130, which is 2A divided by 2A divided by 2, then A is just 130 divided by 2, which is just 65, which is our A, which is 65. Then from there we can get, now we know this one is 65, we know this one is 65. Now we can get ubani this one here, which is A2 and T2, by finding one of these. Either we find the other side or we find the other side, but let's just find the other side here. when we know that T2 plus T3 it's also lingana no A, which is 65. T2 and T3 siyazi ukuthi lingana nobani, no 90 degrees y tan perpendicular radius, which is tan perpendicular tangent yethu. This is our radius from our statement, from our data that we collected here. Then T2 plus T3, which is 65, is equal to 90, and T2 is equal to 90 minus 65, and 90 minus 65 is 25, so T2 is equal to 25. Then from that we know that T2 and A2, they are equal, since O, starting by saying O A elingana no 1 no OT y amaradi, and then A2 angle elingana no 1 T2 ama angle y isosceles, angle is opposite, equal side. Then we can do what sum of the triangle, when we say A2 plus T2 plus 1, the small b is equal to 180, where we say sum of a triangle, our reason. Then we know that T2 and A2, they are equal, and then T2 is 25, so to just say 25 plus 25, and then plus b is equal to 180. 25 plus 25 is 50, then plus b is equal to 180, and then b is just 180 minus 50, then b is equal to 180 minus 50, which is just 180. I hope we understand that part. Okay guys, we just calculated b. Now we just gonna calculate our c by using angle at the center twice the angle at the circumference. Now we're just gonna close it here just to calculate our c on this one. Then we know that c, which is gonna be 2c, because 2c is just gonna be equal to b that we just calculated. You repeat this one 2 times to be equals to this one. Don't make a confusion there. This angle of c, you repeat it twice to be equals to this one. Angle at a center is equal to 2 times an angle at the circumference. Now 2c, we know b it's 180, we just calculated it now, so divide by 2, then c is equal to 180 divided by 2, which is just 65, which is just 65. I hope you see, if this one is 65 and also this one here is 65, there's something that is telling you based on the theorem that you're just gonna do on the next video. Right now, if this one is 65 and also this one is 65, just wait for another video. You're gonna confirm that 65. It's just another theorem. It's just the last part of our work. So thank you so much guys for watching the channel and supporting me. It's very important if you can just press that button, subscribe, and the notification. It's very helpful to the boy. So thank you so much, guys. Thank you.